Let's talk about ellipses and how to draw circles in perspective. So basically an ellipse is just sort of again, it's sort of a circle in perspective, or just kind of a squashed circle, really. And what we need to be able to do most of the time, the real trick is not just to draw sort of an ellipse, is to make sure that this ellipse is actually representing a circle in perspective. And the trick there is sort of to again, make sure that it doesn't look like the circle or the ellipse is kind of off center or sort of wobbly. Now, there's a few ways to do this. One is to sort of rely again on this concept of translating something which is in 2 dimensions into 3 dimensions. So if we have a square, one of the ways that we can sort of start, and we know how to plot squares, one of the ways that we can approximate an ellipse is to sort of fit an ellipse in, or a circle in, the square. Sort of if we see if we can get this pretty close. So yeah, what we'll find is that a circle will fit inside a square. And what we really need to start sort of plotting this is to find some way to kind of find extra points on here, which we can use to sort of mark out a square if it's in a different perspective. Now, there's 2 different ways to do this. One is more accurate than the other. Oh. Let's get rid of this. Okay. And just a really sort of simple way of doing this. Just going to convert these to smart objects so we can mirror them. Again, this has nothing to do with perspective, it's just makes it kind of easier. So you can see again, if we take the same box and make it converge, and at this point, because this is just a 1-point perspective drawing, it doesn't really matter whether this is a true square or not, because a square, i.e. how far the sort of side facing us versus the side going away, what their relative lengths are, that really depends on sort of how far away from it and where we're looking at it from. So if we just draw 1-point perspective and we just have this one sort of simple square here, they're both squares, but we'll talk about how to create an actual square if you ever need to in perspective later. So again, the way smart objects work is that I update it here and it's going to update both of them just so you can sort of see. It should make it a bit easier. So a really good way of starting this is to, again, sort of just divide our square into quarters. And I'm sort of just guesstimating there. But again, to do it properly, you would draw the line across. And let's just draw a line across, get it right the first time. All right, so I save that, and it kind of appears here. So one way to do this is and probably the most accurate way is that we kind of want to divide up this. We want to basically get sort of equal squares around the edge, like this. We want to get divide it up like that. So this is what I'm doing, but I'm just going to try and do it sort of as accurately as possible. So we're kind of dividing it up into four edges along here. Now what we do, so again, if you see that, now that's what's happening here. I don't know what I put that line there for, but anyway, let's keep going. So yeah, we've got this kind of space here around the edge, and the trick is just to consider this to be a single rectangle, and we draw from one side to another. Like this. So again, this one is accurate, but messy and complicated. And doing this gives us a few points which really help to define where this circle is going to cross over. And again, as always, there might be a slight sort of messiness to it because just of the nature of the size of the lines and stuff. So this is how it's done, and if we, what you can see there is that where this line and this line cross, that's where we're putting our mark. Like that. And then what we do is we simply draw a circle that hits those points. And that'll be more or less accurate, as you can see. And if we do this, you can see this is kind of, that's what's going to happen. But as you can see, that's a lot of sort of fussing around, which again is not always a bad thing. And again, all you have to do is sort of go and draw around here. So if I have a go at it, and it's important to understand like that often the circle will touch the edge of the square for a bit. That's a common mistake, is that it kind of sort of goes nowhere. So when we talk about drawing curves in perspective, this is very, very similar to that. That's pretty much all we're doing. Just sort of connecting up points. And you see this is not the best circle. Photoshop is really, it's not good. Wacom tablets are not good for doing this kind of drawing. And I'm not the most expert person at doing it. But again, if we save that, you can see it's kind of, even with sort of poor drawing, just hitting those marks means that it's going to look accurate. And it's, again, you can see we could easily mark and create those perspective lines. And then just do the same thing, just connect up those points in perspective. But if we do it another way, there is sort of a slightly quicker way that is a little bit more prone to accidents, but is fine. And that is that, again, we divide it up. Let's use the same colors. So divide it up. I'm going to try and get this as accurate as possible so I don't have those excuses of it being big lines and stuff. Right, so another thing that you notice is that if we divide this square up again, and we find like the halfway point here, again, there's a number of ways you could do it. You can measure it, or we can just divide this up again. Again, drawing to vanishing points. If you sort of look at this on the ground, you were just drawing these out to vanishing points. And then if we join these lines up, again, just joining two lines up, then what you'll see is that the circle kind of hits just a little bit short of the halfway point here. And we can use this because this is a much easier method of estimation. And you can get quite close by having a good understanding of how ellipses are sort of likely to look, and just sort of using this as a reference point. So again, if we sort of think about halfway point as sort of there, then we could kind of we can sort of estimate a little bit. But let's see if we get a bit closer. just going like this. Sort of saying, okay, halfway point is going to be here. So our line is going to be somewhere around here. So again, that's what we'd be doing there. And really, you don't need to kind of do quite so much of this. You could probably just sort of say, that's about halfway, it's somewhere around there. And we'd probably get sort of close. And we'll have a go at that sort of later, so we can see that my guesstimation is, yeah, it's kind of fine. So again, we mark these points because we have these points, and that's going to give us a good sort of ellipse. So again, if we were to sort of do this ourselves, it would just be a matter of, let's have a go at doing it. Get rid of, no, let's keep that. But I'll leave those estimates on. No, I won't. I'll do it again. Otherwise, it's kind of me using Photoshop too much. So all I'm doing is I'm just saving time so that you don't watch me sort of calculating sort of basic perspective all day. But if we do this basic division, and then we sort of draw, we're drawing a square within a square. So let's take this. So then I've got this guy here. And what I can do is sort of go, okay, halfway might be sort of there, halfway might be there, halfway might be there, halfway might be sort of here. And then what I can do is I can either sort of mark on some extra points, or I can just sort of try and draw an ellipse and try and sort of just not hit, like not quite hit. So we'll try maybe a bit of both. So here, I'm just going to go to pick another color maybe. So we know that circle is going to be sort of here, and it's going to hit this. And then it's going to come over here, it's going to hit this. I know here it's going to hit this. Might come out a little bit more. Needs to hit just a bit before that. you can see, it's a lot easier in your head to hit marks which exist, which is why it's worthwhile sort of putting points down. So again, it's not fancy, but it'll do the job. So that's the basic idea. This is probably what you'll end up doing the most if you sort of actually have to do it. If it's something really critical though, and it really needs to be sort of tight, this is the thing to use. There is one other way of doing it, using Photoshop. And that is simply, we have our square, or maybe let's do this, get another one. So you've got your square. It doesn't have to have anything in it. And all we need to do is sort of create a sphere. And you can either stroke the sphere at this point, and then if we transform, what you'll see is that these points, if I lay them out, this is basically exactly what's happening when we create it in perspective. So I'm using free transform. You hold down the control key, and this will let you move those points. And now I've got a pretty good circle in perspective. The other way to do it, because what this does with this curve is it's actually transforming the rasterized line. You could use the transform selection tool first, if you wanted to get a really kind of quite even line going here and there, and then you can stroke. And that is the cheapest, easiest, cheatiest way to do it. It is really important to understand how to do it these other ways though, because it's not that hard, it's not that tricky, really it's just simple sort of abstract geometry. And if you're doing it in your sketchbook and you don't have that Photoshop tool or whatever, it's good to know how to do it. It's very sort of low impact to figure out how to do this. Again, it's one of those things where you may not do it every day, but if you do need to do it, you know there is a way. Even if you forget the geometry of it, you can always go and look it up, because both of these things probably will come up. You know, I think this one's in the Loomis book, in you know, some of the Andrew Loomis books. This one is just, if you search like drawing an ellipse, this one will come up on Google. But this one is really where you can leverage Photoshop to do some of this stuff. Now that is move these guys over here. Now that's sort of how you would do. Let's move these guys over here. So that's kind of how you would calculate it if you had the time. But you know, we don't always have the time. So it's important to just understand a few other things about ellipses, which can really help us place them in perspective. Because frequently an ellipse is part of a cylinder in some way, shape, or form. This is kind of just how they're arranged, in the same way that the concept of a 95-degree angle, or a 90-degree angle, sorry, which is, you know, kind of like a square angle, is really important, and we use this a lot in the geometry of perspective to actually calculate. things like a true, just things like, how to get sort of an actual sort of square and things like that. This is how it's done, is because we often make things sort of true, i.e. 45 degrees, 90 degrees, just because they, again, relate to gravity well. Often an ellipse is part of a cylinder, or it's part of wheels, which are kind of connected to an axle. And this is a really good way to think about some of the other things which are important about ellipses. So an ellipse is kind of a squashed circle. And it has sort of two axes. I think it's axes. One represents the wider part of the ellipse, right? And this is the major axis. Because it's the bigger one. And this one is the minor axis. Because it's the smaller one. And we can use this concept of it having a minor axis and a major axis to place it in space. And there's a couple of reasons why. The major and minor axis are always at, they're almost always at, given that the perspective is good and we're not doing anything else sort of stupid, and that we have a good sort of, we're not in a level of distortion, perspective distortion, using like a massive wide-angle lens or something like that, trying to do something silly that's going to look off anyway. But generally, if the wheel is going to look in perspective, then these major and minor axes are going to be at 90 degrees. And it's important to understand that they're not at 90 degrees in perspective. They're actually visually at 90 degrees. Two-dimensionally, they're at 90 degrees. And again, often these things are calculated, all of these techniques were sort of started from when people were doing these things, with set squares and T-squares and rulers and all sorts of, old school drawing paraphernalia, which, was still in use heavily sort of 15 years ago. Now, not so much. So, this concept of having like a sort of a triangle that you would draw with was very common. So, but in Photoshop, often it's a bit like, well, how the hell do you get 90 degrees? The concept is just visually that it's sort of like 90 degrees is sort of, they're perpendicular to each other. Meaning, again, this is perpendicular, this is parallel. Perpendicular is kind of the opposite of parallel. So why is that important? Well, it's important because often when we're drawing ellipses, we actually have a center line of that object. So the center line of something like a car wheel would be sort of like the car axle, perhaps. Or, if we're sort of drawing a cylinder, the center line of the cylinder is good to put in from a construction point of view. And what this means is that the major axis of the ellipse, i.e. the line between the two widest points of the ellipse, is always going to be sort of visually 90 degrees to the center line as well. Because, and this is probably the most important thing, is that the center line will always line up with the minor axis. If you take nothing away from this whole thing besides this will be key, is that when drawing ellipses, the center line of the object or the center line of your cylinder, or because again, an ellipse is rarely sort of a flat, just ellipse, often it's sort of a part of a structure, is that the center line of that sort of tube, and even if there isn't a tube, you are advised to draw a center line so that you can manipulate this perspective. So the center line will always be perpendicular to the major axis. They'll always be 90 degrees. Visually, like actually 90 degrees. If you put an actual, again, if we get a square, and we get this and we transform it, we imagine this is our old sort of triangle. It'll fit in there. It'll create sort of a perfect L shape. And so what this does is it gives us these two things. It gives us the minor axis and the major axis of that ellipse just by drawing the center line. And the center line of an object can often be related in perspective. And that's really the key here, is that when you have a car wheel, you have a car axle, and the axle is often sort of going into perspective and is sort of converging. Again, I'm just going to draw sort of a pretty bad one here, but you've sort of got the cylinder of the car, and then of the sort of axle and the car wheel, and then you'll sort of have other sort of body parts. Like the windscreen or whatever, and these are all sort of going into perspective too. So the axle, or the sort of the center line of your cylinder or object is often going in perspective. So this is why we can really use this. So now I have basically the widest point. So the widest point is going to be here, because again, if I get my fake square and I sort of put it here, oh, actually it might be a bit more like this. What this means is that I can then sort of try and draw an ellipse around that, and I know that the smallest point is going to be here, and the widest point is going to be here. Now, what are some other things we can use that we know about ellipses to help us get more accurate? Because as you can see, that was a fairly poor job of it. One thing that we do know is that both sides of an ellipse are equal. So both sides opposite the minor axis. If you have an ellipse and you split it down the center, that might we've got, again, the major axis is going here. This is 90 degrees. What happens is that both of these sides are symmetrical. So we know that if you kind of folded it over, that they'd match up. So that's kind of important to understand. And what that sort of does now is it lets us approximate an ellipse, and basically the next step is either to draw in a cube so that we can define the ground plane, and then draw in these and then use all of these other aspects to basically define where that ellipse goes. Or you can just get very good at guessing what angle of ellipse, and the angle is just how open the ellipse is, whether it's sort of we're looking sort of more straight at it or more kind of at the side, like whether we're sort of looking at the top of a wheel or sort of at the side. So the angle, you just can just get good at guessing sort of what angle of ellipse is going to needs to be there. But the other thing is, now you can sort of see that, say we have a sort of a simple box. Like this. And we sort of say, okay, this simple box is sort of going in perspective like this. Again, this might not be a perfect square, which would kind of mess this up, but we'll have a go. So we've got the center line of this object is sort of here somewhere. Again, I'm just sort of guessing. We can sort of find it. And again, if we use this kind of method here, but I don't know it's a square, right? That might sort of put me in trouble. But what we can do is we can use all of these issues and sort of try and approximate what's going on. So I know that sort of in this case, this is sort of fairly, in fact, this is kind of on the horizon. So the minor axis is going to be here. The major axis is going to be here. And that the ellipse is going to sort of hit some of these points at least. And the trick then is just to kind of make sure that I've got all of those issues happening. And then try and make sure that it fits. And that'll kind of give us a close approximation. So I think in this case, because they're kind of, it's on the horizon, that's probably not the best example. Let's do another one. So again, we've kind of got center line here. And as I draw this ellipse, I've kind of got to get it to sort of fit all of these sides. But again, this might not be 100% square. But if I follow the rules of an ellipse, then what I sort of draw around here will actually be representing a circle. And again, we can approximate with a box to make sure it sort of fits in the right space, and then we can again sort of draw this ellipse. Again, if we sort of go back here, just a matter of sort of drawing again this the major axis, which is going to be 90 degrees, and I just draw an ellipse in here, but we draw it a little bit more open. Because it's more like we're looking more at the side of this ellipse than we are of this ellipse. And this way, if we keep the ellipse following these rules, then it'll kind of always be a circle that's viewed in perspective. Whereas you can see here, this really relies on it being a true square, because what happens is if we're sort of doing this, and this one's a bit confusing. So, but if you kind of have an unmeasured sort of object in space, then what we can often end up doing is sort of actually, this might be not quite a square, it might be sort of more like this. And these rules aren't necessarily going to apply to this. Some of them might, but often we're drawing much more of the concept here is to make it look like a circle. Because again, circles are important because we use circles for wheels, not ellipses like this, not sort of oblong ovals. So yeah, again, you can see if we kind of divide this up and we kind of measure here and measure here and measure here and sort of do this sort of thing, or it'd sort of be like, yeah, here. If we do this, then we might actually kind of always end up with something. What you'll end up with is an accurate curve. You'll end up with an accurate representation of this, but not necessarily the concept of a wheel. And they're different. And a wheel needs to look like a circle. And we can sort of tell whether something's a circle or whether it sort of is looking right or not. So focus more on these than sort of if you're building wheels from sort of, specifically trying to do this. If we follow these rules, then it'll kind of always look as if it's a circle, and it'll look as if it's kind of, it's got that right feeling. And so you can see here, if we kind of match the size and depth of this, then we can sort of start to approximate the right size. And if you kind of line all these things up, you should get very close. And yet often issues like this are just like getting the right ellipse is just a matter of sort of practicing, really. It's just sort of understanding what the ellipse is going to look like. Because even with this, it's sort of still possible to sort of draw the wrong ellipse and make it look as if it's a little bit warped. So using some form of sort of square, or like drawing the center line down and defining the height is probably a really good useful thing to do, because that will kind of, if you fit an ellipse in there and it matches all those criteria, it should be relatively correct. There's a couple of points where this will fall down that again I've kind of heard people talk about, and that is that when you get to the levels of real distortion in 2-point perspective, sometimes this is gonna fall down because this is no longer going to be 90 degrees, because again 2-point perspective is an abstraction, and it's a way we simplify sort of a more complex world. And basically once you get to the levels of distortion in 2-point perspective where we kind of have we're sort of drawing boxes and things, and if we sort of are starting to draw things like right out on the edge, then what happens is that really what you need to do at that point is draw it in 3-point perspective, because it's starting to abstract and be artificial. So kind of in the center of a 2-point perspective, we've got a fairly sort of good field of view, whereas we get out to the edge, what we're having an effect of like a wide angle lens, but the actual perspective can't support it, because what would happen is that these sort of uprights and things would curve, but instead we're trying to keep them simple, and that will affect this concept of it being true, because basically these lines are sort of stretching out more than this, which we're keeping vertical, will allow, and you'll get some distortion there, which will mean that some of these rules won't apply. So again, if you're kind of dealing with a lot of distortion, you're like, oh, this is not quite matching up, then yeah, it may not entirely match up. But probably if you're dealing with that sort of distortion anyway, you probably are going to need to guess a bit more, and you probably also should be converging the verticals a little bit, which will kind of make these things true up. So yeah, generally these rules will apply in most cases, and really it's just a matter of sort of using as many points as you can to approximate where an ellipse should be, and then just get very, very used to sort of drawing ellipses, and get used to drawing them around sort of an axle or a center line, and make sure that they're always symmetrical, because that way they're kind of always going to be looking right, not as if they're kind of a bit off, or yeah, all over the place. So again, these are just simple observations about sort of what happens to certain forms when they sort of become converged in perspective, and we can use them to help us draw things like wheels and cylinders and all those kind of objects.